Yes, once again, I welcome you all for another presentation on this mechanical translational system. By the way, it is lecture number 19. It is the continuation of previous lecture itself. So, in today's lecture, just I would like to explain you one example on the topics which we have seen so far in our previous, lecture number 17, we have seen some introduction part, as well as in a previous lecture, that is lecture number 18, we have seen some more introduction part. And in this lecture number 19, just I will explain you that one problem normally. So, I am going to explain you. Let us see that, see, there is a problem is given like this. This is nothing but the reference line. Actually, you can see it is a reference. Normally it will be denoted like this only, and you will be having, it is given one mass element. This is mass. Let us say it is given x, or sometimes they will give you x of t, nothing, okay, and force f of t is given like this, and then between this reference line and to the mass there is a spring is connected like this, it is k, and this is also called as b, nothing but your dash part element. And here between these two, this reference line, normally it will be shown like this. Basically here we will have some friction, viscous friction coefficient, that is normally can be represented as b1. As you have m, normally it will be given as b1. Okay, so this is the given problem. So for the given problem, okay, find out or write down, the first question is write down the differential equations, or the difference the differential or difference equation associated with this mechanical system. And second is find out the transfer function. Find out the transfer function for the given problem. So this is the given problem. For this we need to find out the differential equation, okay, and later on subsequently we have to find out the transfer function. Now let us see the solution for this problem directly. Okay, solution part. Okay, now for this given problem you need to draw the free body diagram. I think we have already discussed in our lecture number 17. Okay, so in the solution part, okay, you need to draw the free body diagram first. What is a free body diagram? Free, okay, you have to draw the, okay, the free body diagram. You need to draw the free body diagram. Okay, you have to draw the free body diagram of this block. It is nothing but, I will erase and I will show you that a free body diagram is nothing but you have to represent all the forces acting on that particular body. Okay, so The free body is like that. So what are the basic, otherwise what are the elements are there in the given problem? F is there, f of t is there, x however displacement is there, and mass is there. This is spring constant, this is called the dash part, this is called the viscous friction coefficient. Okay, these are the things associated with this block. Now the free body diagram, I will erase this. I will draw here for you. So the free body diagram is like this. The free body diagram. Of given mechanical system, of given system, you can say otherwise. The free body diagram is like this only. You just draw the block mass, this is the M, and you just identify, you just represent what are the forces acting on that. So here this is due to Fm, force due to mass, this is force due to K, spring constant, this is force due to dash part B, this is force due to B1, is it not? So upon this you have force, you can represent f of t like this, this is your applied force. However, your x of t is there, basically you have to show your x of t as displacement. This is what the free body diagram, this is called the free body diagram. Just you draw the block and identify the mass like this, and then you just represent all the forces which are acting on that body. So the first force is with respect to mass itself, that is the, with respect to mass we will have some force, that is Fm, and with respect to spring constant K, it opposes opposing forces otherwise. So mass, okay, this is the force opposing by mass, force opposing by spring constant, force opposing by the dash part, and force opposing by the viscous friction coefficient, and finally this is the applied force. Okay, this is what the free body diagram. So from this you just draw that, you can sum all these things, nothing but your f of t is nothing but your applied force is nothing but sum of all these forces, sum of all these forces, or is it not? So f of t is equal to, what is this? F of t is equal to total force, that is Fm plus Fk plus Fb plus Fb1, that's all. Fm, Fk, Fb, Fb1, all these forces equal to your f of t. This implies, then what is Fm? Or f of t is equal to, what is Fm? Directly you can. So I already explained you that in last presentation, wherever Fm comes, m into d square x by dt square. Okay, m into d square x by dt square plus, what is Fk? That is k into x, because you have x only, k into x, plus what is Fb? That is b into dx by dt, plus what is Fb1? Nothing but your b1 only, b1 into dx by dt, because both will have same purpose only, that is friction, that is dash part, both b's will have same meaning otherwise. So this is what basically. So first of all, if you equate all the forces, I mean all the forces, this is force with the mass, force with the spring element, force with respect to your dash part, force with respect to friction. If you sum up all these things equal to 0, equal to 0. This is what your difference equation. This is what your differential equation. Or otherwise, you can obviously all these forces equal to your F also, that is nothing but F of t. F of t. F of t is equal to this one. No? This is what your differential equation. This is what your differential equation. Now, for this equation, what we need to do? Apply the Laplace transformation. Let us call it as equation number 1. Let us call it as equation number 1. Now, for this equation, you apply the Laplace transformation. Okay? So, I will erase here. So, by applying Laplace transformation, it is called Laplace transformation to the equation 1. To the equation 1. So, apply the Laplace transformation to the equation number 1. This implies then how it becomes Laplace transformation of your f of t is equal to Laplace transformation of, you write all this, that is m into d square x by dt square plus k into x plus b into dx by dt plus b1 into dx by dt. That's all. Now I erase this also. This implies L of t of f of t is nothing but capital F of s, as I already explained you in the previous presentation. Now L of t of this particular element, this becomes m into s square into x of s. Is it not? M is the constant. Second derivative comes as s square. Your x becomes x of s plus apply Laplace transformation here, k into x. K is the constant. Your small x becomes capital X of s plus b is the constant, and d by dt. Apply the Laplace transformation to this d by dt. There is one derivative. Then you will have s into x of s plus same here also as like this b1 and s into x of s. This implies take in each term, this is the first term, this is the another term, this is third term, fourth term. In all these things you will have x of s. No, take x of s as common. Take x of s from all these things, then you will have, okay, what you will have? M into s square, is it not? ms square plus then it is k, because x of s we have taken as common here, plus here x of s we have taken out, then b into s plus here also b1 into s. So your problem is over. This is equal to x of s, and further you simplify. This is ms square plus there is a s term. In these two again s is there. Take s as common here. If you take s as common, it will be b plus b1. Is it not? Because it is a second order equation in terms of s. Therefore s square, next s term, it is s square, it is s power 1, s power 0 has to come basically, no? So therefore ms square I have written first, and in these two you take S as common, then B plus B1, and finally what will remain? K. K. Close the bracket. This is what your f of s is equal to. And finally, what is the transfer function? I already told you, no? What is your transfer function? Transfer function is equal to, normally what is the output? That is the x of s. Okay, x of s. X of s by f of s. Your input, applied input, f of t is the input, x of s is the output. So x of s by f of s. So x of s by f of s, if you take the ratio here, so you keep x of s here itself, then you bring all this quantity which is there in the bracket to the left side, then it is in product. If you bring in the left side, it comes in the denominator part. So 1 by, so it comes as 1 by, what is that? ms square plus s into b plus b1 plus k. This is what your transfer function. Put in the bracket. The total you can put in the bracket. So this is what your transfer function. Understood? Very simple, no? Very, very simple. This is what the transfer function for the given block diagram, for the given physical system. Likewise, we have to find out. So, for any given problem, we need to draw the free body diagram. Free body diagram is nothing but it is a just raw diagram. So, you just draw the block and indicate all the forces acting on that physical, mechanical body, and then by applying the Newton's second law, you write the force balance equation. F of t is equal to, and all the forces you sum up, and then that itself is called the differential equation. For that, you need to apply the Laplace transformation, and finally you will get the ratio x of s by f of s. Then it will be like this only. This is the transfer function. This is the very simple example, and in the next subsequent presentation, and we will see little bit bigger one also, bigger problem, or a little bit complex problem also. Okay, so with two blocks or sometimes three blocks they will give, and their interconnection will be given, means some between the two blocks there will be common spring constant, common dash parts will be there, like that they will come basically. That we will see in the next presentation. So with this I will close this presentation with this simple example. I think you understood the basic concept of this mechanical translational system. So this is the basic things that is involved in this mechanical translational system. If you can able to understand this, and you definitely will you understood the concept of mechanical translation system itself. So it is such a easy topic. I think you have enjoyed this. So I thank you once again, and then ask you everyone that to comment and to give your feedback, your suggestion, and definitely don't forget to share with your friends, and we will meet in the next presentation. Thank you. Good night to you all.